Last month we talked about the universe and how things began there, and then we shifted into what makes our planet special and the concept that our planet is set up for not only life but also discovery and learning and science. Like things like the moon being exactly able to eclipse the sun so that we can see the heliosphere and learn about how the sun works and how it was able to prove Einstein's theory of relativity with the curvature of light around the sun from stars that were behind it. So we're shifting from that to much, much smaller. We're going into life itself and cells and like the chemistry of life and how it could have started. It's a big it's a topic in science. It's usually called origin of life studies. There's a lot to that. So we'll start by just saying what science holds to now, right? So we've talked before that science kind of holds this materialistic assumption underlying their science. So they are looking for evidence of how life could start without intervention, like through natural processes. How could that happen? That's really the question they're trying to answer. So they would say like life originated from inorganic material through chance-based processes. So I think we all can remember back or have heard of the primordial soup idea, right? Like early Earth, like there's a slime puddle that's being heated by lightning or even like geothermal vents, and like there are these chemicals that are stirring about, and like they managed to form the first simplest organisms that could reproduce, right? So like that's the key, is like how do you create something complex enough where it can reproduce itself and then kick off Darwinistic evolution. And that idea is pretty much widely accepted. That's kind of how it happened. Most scientists would not say we know exactly how it happened, which is good because we don't. But they are very optimistic that we'll figure it out and that progress is being made, and we'll come back to that.
It's also been presented though, like in media, for people that aren't digging into those papers, that it has happened.
Yeah, that's a good aspect to talk about. So like I don't know, like it might be like Google's bias towards me, but I end up getting a lot of like headlines about like origin of life research or science research and stuff like that. Or you see these headlines like science creates the first synthetic cell or key missing building block discovered, or even more recently like amino acids discovered on asteroid samples. The building blocks of life is a lot of times how it's phrased, and they're very sensational headlines, and it makes it seem as if we are we have a pretty good handle on how this all works. And even there's a study that Dr. James Tour references in some of his talks where it talks about like, I think the questions are something like, how many people think that they've created a frog in the lab? Or something like a frog in the lab.
Yeah, it's a frog because they did a survey. Yeah.
And it's like something like a third of people think that like we can create something as complex as a frog in the lab, which is just
out of nothing.
Yeah, like just synthetically.
They claim that they really have created a frog.
They haven't, but that's people's assumption. So like people were polled and said, do you think that scientists have created a life form as complex as a frog in the lab? And like a third of people responded yes.
Yeah.
Okay. And then the next question was like, okay, it was like, do you think that scientists have been able to create like single cell life in the lab? And it was like something like 2/3 of the people said yes. So we're talking 66% of the average public believes that science can make synthetic life, more or less. Which, spoiler, is not true.
Do they say out of nothing when they ask the question? Or do they just assume that that's what it means? Or
I don't know if
that's
I can't
kind of a
remember
big part of the question.
I think it's from like non-life materials. So like not necessarily out of nothing, but like out of like minerals and
what we have it or
things that aren't alive, like making things that making life from things that aren't alive.
And these are average, non-scholarly, like they went out into the public and they were like, would you like to take a survey? Like, what are your thoughts on this based off of just life experience, like in your 20s and your 30s, 40s, 50s, etc. And I remember when I was in my teens, and which would have been in the 90s, right? Yeah. Anyway, and I remember seeing an article somewhere, I don't know if it was in school or what, but I remember seeing an article that freaked me out even as a kid because I wasn't a Christian, but like God was very important to me. And I remember seeing an article that they had created cellular life in a lab. I remember seeing that article and panicking as a kid because I was like, what does that mean? Like, what are the implications of that at 15? Like, that must be really scary. Of course, I didn't read it, but I saw the headline and I was like, that's not something I can touch. Like, science is scary, science is evil, science is bad, this is not good. But even back then, like, this is not new.
Yeah, because even if you read the article, it gets
skewed.
Quickly scientific.
Yeah.
Or like there's a lot of big words and a lot of science concepts and you're like, okay, I'll trust what they say. Something like that. Like,
or ignore it.
I mean, let's be fair, most people don't read the articles anyways. It's just headlines. That's how we get a lot of our news. I mean, still even today, like I have to be really interested before I click into an article. Otherwise, I'm just like, I get the gist from the headlines and the intros and stuff. But okay, let's back up and talk about the cell itself and how it's fundamentally structured. So cells are, you can think of them as like mini factories. Like they have jobs and like there is like assembly lines and there's a lot of things going up. They're basic, but at the simplest, they're factories that create proteins. Like that's what cells do. And what's a protein? So a protein is a chemical that is composed of amino acids. Amino acids are just a simple, like a compound, and you put bunches of these like amino acids together in chains, and you form a protein. And that protein has a function in the cell. So you can think of amino acids like letters and proteins like words. So, you might have amino acids. Well, the interesting thing is like there are 20 fundamental amino acids that pretty much all life on Earth uses. Like 20 amino acids, that's it. For trees, viruses, bacteria, humans, all of that. And those are basically the letters of the alphabet. Coincidentally, it's about the same numbers of like we have 26 letters in the alphabet, so it's around the same. But the way you order those creates words, and you can think about the English language. With 26 letters, how many tens of thousands of words do we have? Lots. And then you think about how many, if you start randomly putting letters together, how many times do you make an actual word? Like, not often. Most of the time it's nonsense, right? Like, you start just randomly picking letters, like alphabet soup, you take a spoonful and you see what letters are in there, and you're not getting a word most likely in the right order. Amino acids are very much similar to that, where you need the letters in the right order to achieve a function. But proteins it doesn't really stop there, because proteins can also combine to create more complex machines. So you can think of that as like paragraphs. And those paragraphs then form systems, which then, chapters, and then a living cell is the whole book. And we're just talking about a cell. We're not talking about a human being here, because now after that, you actually have more systems. You have groups of cells and types of cells that form organism structures in the same way that a cell has structures. Cells are very much smaller versions of you and I. Like, they have organs, they have mechanisms in there, they take in energy, they expel waste. Like, every cell in your body is doing these things internally on an individual basis.
This is amazing.
Yeah, it is pretty crazy. Like cells are incredibly complex, which is interesting. Okay, so let's back up in history a little bit. So like during Darwin's time, when Darwin came up with his theory of evolution, what did we know about the cell? Does anyone know?
Extraordinarily simple.
Yeah.
That's what we thought.
Yeah.
Mhm.
Yeah. So during Darwin, which, in the early 1900s, we didn't have a good handle on how cells worked or even what they were or their role. They were just basically seen as little blobs of jelly. They called them, what did they call them? They called them protoplasm.
Yeah.
Is that right? I think that's right. And like they were just seen because like at the time, like the best microscopes, basically that's all they saw, right? They just saw this little blob of goo, and they're like, okay, like that's the Lego piece that makes up human beings, and that was it. So like during Darwin's time, even Darwin proposed this idea of, he didn't call it the primordial soup. I think he called it like a puddle or something like that. Yeah, a warm little pond is what Darwin said. And like he was like, okay, you got a warm little pond, and it's like, okay, eventually, some kind of little goopy blob thing forms, and then it can replicate. And like the complexities of the cell really weren't understood or known. So it was honestly more plausible of an explanation in Darwin's age, and it's from there things just got a lot worse for trying to figure out how these things, like the complexities of them. Excuse me.
Isn't there isn't it entropy that says things tend to disorder anyway, like rather than come together and form something complex and
it's a law of thermodynamics that things tend towards disorder or in homogeneousness, right? So like you think about, we talked about coffee earlier, you pour creamer in coffee, for a while it's complex and it's swirling and stuff, and then it just kind of, it becomes
one cohesive liquid.
Thing, and nothing really interesting is happening at that point.
Yeah.
And like that's a good way of looking at how cells and life works, is life sits on the balance of this, like you need that chaos of the creamer mixing with the coffee to make these chemical reactions and do all these things, and you're constantly trying to live on that edge. That's why you need to constantly pour energy into that system, like continually pouring creamer in there and coffee in there to always have that like balance of chaos in a way, or it's unstable stability, right? Like it's kind of weird, but you kind of got to stay right on that edge, right? Where it's like, okay, I have enough energy to make these things happen and have this work be done, but I also need to make this a system that can repeat over and over again
without mutating. Because if you continue doing that as humans, like if that continued working as we are in our own bodies, if it stopped, you die. But if it continues, like you are growing tumors, you are growing third legs, eyes, arm, like evolution continues from a Darwinian perspective, but it goes terribly wrong. So yeah.
So go ahead.
So like for historical context, Darwin lived from 1809 to 1882. Was science at a place where he would understand that things like devolve instead of like they would go from? I'm trying to understand like his mind.
He would have had the concept of like the like he would have known the laws of thermodynamics, because like those kind of I think those go all the way back to like Newton-ish.
Okay.
And like there is like so they would have had some of that, but like that's why reproduction is so key, because like that is fighting those laws of disorder, like by reproducing. It's like okay, so like we all have lifespans, right? Like it's like, okay, we can live so long, and then like the system starts breaking down in ways that we can't stop.
Right.
So the answer to that is reproducing, so that life can continue past us. And so like that was seen as like, okay, if you can get to this point, then it cycles and builds on itself. Is the argument.
Yeah.
I wasn't sure if I was going to talk about, but today, right now, like leading origin of life. I was just listening to this week. There's a researcher named Lee Conan, and he just released a paper introducing this theory called assembly theory. And his goal is to mathematically have an equation. It's a fairly simple equation in regards to equations go, but it kind of quantifies the complexity factor. And like in the paper, it says like anything that results in an answer above 15 is an indication of life, in the sense that like like once you pass this boundary, life just kind of kicks off and is inevitable. And like there's a lot of aspects to that, and I'm still kind of digging into what it is myself, but it's almost, in my opinion, it seems as if they're acknowledging the complexity and that it's highly, if not impossible, for things of a complex specified nature to exist without some sort of memory. Like, okay, this is how I build a protein. Like, you need that so you can repeat the process. You need this repeatable instructions. You need to like save that information in order for the assembly to continue. So I was listening to a few things, and I never really got a clear understanding on what that saving mechanism was. Like, that's what I was really interested in. And I don't think they propose one. I think it's just like at some point the chemical information gets stored in a way that it can be repeated and re-executed.
Right.
Just like that's basically the job of DNA in the cell, right? The DNA is those instructions for the cell and the organism on how it should function. So you have that saving mechanism in DNA, but then like, how do you get that before DNA existed? There's not a good answer for that as far as I've heard. So like, basically the whole, like, they admit they don't know mostly. Like, headlines are one thing, but like scientists know, like they know that like there are big problems and they're trying to solve them. Which, great. Like, I'm all for them trying to solve that and try to figure out things. As you guys know, my assumption is they're going to find out that God has done some amazing things. And like, just because we know just because we think we know how gravity works doesn't make it any less amazing that God made it that way, right?
Right.
So
I guess this is really helpful, because I guess in my life and knowledge, you look at things that they have an appearance of simplicity in almost every arena of life, and then the deeper you dig, you're like, oh my goodness, there's complexity in this. Let's say scientifically, in this organism, there is such complexity. It appears simple, but it has complex. Now, from a pastor's side, it's like you can see people. It seems simple, but then when you dig in, counseling ministry is kind of like, oh, it's all very complex. It's all very, and we have to go here. Businesses are built very. It appears simple. This is a simple business concept, but if you meet the owner of the business or the founder of the business, it's very complex. There's always a story of how it worked, and there's complexities that have led to the simple tasks of, let's say, a business. So I'm trying to think through like Darwin's mind in the 1800s. Like, he's a smart guy. He's a fairly religious person, and yet. Is he, I guess I'm trying to get the ethos of like, is he going against the grain of his culture to say something simple developed into something complex, which now we know, it seems like evidence keeps building to like this idea of very complex that devolves eventually, like our bodies eventually will, it's a very complex structure that eventually devolves when we die. But is Darwin? Does he feel that? Does he sense that? And I have not read any of his writings, so I don't know. Like I'm going against the grain to say simple brings complex.
There was a big unknown. Like they just didn't understand how life could have formed at all. You know, because like we can look at something and be like, that's a rock, that's a frog.
Mm-hmm.
Like the frog's alive, the rock is not.
Mm-hmm.
Now, once you start trying to say why, that becomes a lot harder. Like, why is the rock not alive and why is the frog not alive? Well, the frog can reproduce, and like you start characterizing what makes something alive. So, like Darwin, like there was a big mystery of like, okay, how does this happen?
Mm-hmm.
And like, you know, classically, Darwin went to the Galapagos Islands and he saw the finches, and he was like, okay, I see that these finches have different beaks for different situations.
Mm-hmm.
So like they're basically the same thing with small variations.
Mm-hmm.
And so he proposed that natural selection, that is the force which says that like the birds with the right beaks to eat the right food are going to survive.
Mm-hmm. Okay.
And like, so he's like, okay, I've discovered a mechanism which allows changes over time.
It's deduction.
Yeah.
Like he just watched and deduced.
Yeah.
Mm-hmm.
But like we were talking about this a bit yesterday. I didn't mean to interrupt you, but like there was a lot happening
Mm-hmm.
in this era. Like we have the Industrial Revolution kicking off, which means we are creating technology where you can say the frog's alive, the rock is not, and then we created these mirrors and these lenses that allow us to look at the rock even closer and notice that there's life on the rock.
Mm-hmm.
That's very small. What does that mean? How can something not alive have life on it? And also, I mean, I think you know the timeline better than I do, is like religious life was becoming more open, like where you weren't going to get stoned to death if you were like, I don't know if God created all of this, or I don't know if he created it the way they're saying, like this group is saying that it has always been done. So sorry.
No, that's good.
Good.
So like to answer your question more directly, like prior to Darwin, there was the best explanation for life sounds ridiculous today, but the best explanation for life was spontaneous generation.
Yep.
So
Like,
they proposed basically
germ theory was happening at that point too.
Okay.
Yeah.
It was have you heard of miasma? Have you ever heard of that?
No.
Okay. So the idea was like the Victorian era. It was the same time frame. I'm almost positive of it.
around
But
there.
like they were discovering germ theory, not knowing what germs were, but the idea was people got sick because of bad air, which is not totally wrong, because like if you are living around a pile of garbage that smells really bad, you probably also have disease and putridness and you're going to get sick. But the idea was that if you, like, people during the plague couldn't understand why some people were getting sick, and so when they got sick they were like, smell this flower because it smells nice. And so there was this idea that there was something happening within the air, and they were just watching and observing with no means of going deeper into it to determine why are things happening, why are people dying, why are people getting sick, why are pustules erupting on people's bodies. And they weren't attempting to deceive, they were just watching and attempting to explain, and they had this recipe for life that they assumed.
It's not necessarily like observationally. So like they're just observing life around them from what they understand, and they're like, okay, if I leave a piece of meat out, maggots show up. So they're like, they spontaneously come. Like they weren't seeing the flaw. Like they weren't making the connections of what was actually happening.
Recipe for a mouse.
So much so, this calls it out here, that in the 19th century, a scientist named Jan Tista, they had a recipe for creating mice. And the recipe was, place a dirty shirt or some rags in an open pot or barrel containing a few grains of wheat or some wheat bran. In 21 days, mice will appear.
Yeah.
So
that is so great.
Yeah.
That
is
that
fantastic.
is what the foundation of Darwin's was like. Things just show up and like they kind of do if you just observe
What was that
it.
called? Spontaneous
Generation.
So Bacon, what was his name?
Francis Bacon.
Francis Bacon, very famous guy, loved the Lord. Like, he was a Christian. He was a big name in science. But we get refrigeration from him because he would take raw chicken. He would take a chicken, he would kill it, and he would set it outside and be like, oh my gosh, cold temperatures seem to stop decay from happening. Unfortunately, the poor guy didn't even consider that he was also a live person. Anyway, he died from pneumonia from experimenting. But it's
Okay.
the reason I say that is these ideas, right? We listen to a recipe for a mouse, we listen to a recipe for maggots, and we're like, that's ridiculous. How dare they? And we look at Darwin, we're like, how could he possibly? But we're doing that today.
Sure.
Like, we're looking, like, you've got origin of life people on both sides of the aisle. One saying like there is a creator mechanism, and another side saying no, there's not. It's random. And they are both looking at each other as if one is writing a recipe for mice. And like, we might figure out how life has worked. And Jake and I were talking about this yesterday. James Tour is like, I hope we figure it out. Maybe we will. And when we do, what we think now is going to be like these recipes for mice. And so humility is huge. And that's where this split down the aisle is you've got so many people thinking that they're so beyond Darwin, and he was just trying to figure out stuff, that we are missing a lot. Like, we miss bringing people together over donuts because people want to assume that they have it figured out, and humility equals like unknown.
Yeah. And like, I think that's a good warning for us who are skeptical of the current like prebiotic soup and stuff. And it's easy to be like, oh, that seems ridiculous. And I mean, it does. Like there's no good explanations. I think that's the part that I'm most critical about in it, is like, okay, fine, that's how you are saying that this happened, but like, I need more specifics. Like, how did these proteins form? And like, those are things they can't answer, so they can't go into the specifics, but be honest about that. Don't present it as this like explanation when it's really just this broad, like, it could have happened this way. Like be honest. I think that's the thing that I'm most critical about in it. Isn't necessarily like, oh, these origin of life people are wasting their time because God created everything. Like, that's too simplistic. Like, we can understand, God's given us the ability to understand things that he has made, and life is still a mystery to us. Maybe one day it won't, but I am confident in my assumptions that when we do figure it out, it'll give God glory. If and when we figure it out, it'll give God glory. But, I understand that that's my bias. And I think that, people who are trying to approach it from a materialistic worldview aren't necessarily like the enemy. They're just, I think they're missing something significant, which is the agency. Like, I think there's clearly an agent behind these things, and like the complexity speaks to that. And if you just throw that out, like, that's going to stunt your science. So like, that's my challenge to them, is like, okay, work through that, like, don't just dismiss this that could be a legitimate thing. Like, just from a scientific perspective, we are agents who make things like donuts and coffee, and like, so there it is. There's your like proof. Like, it happens. So just like, we have donuts and coffee because we are agents who made them. Donuts don't just appear through natural processes. So that's evidence of an agent. Now, life doesn't seem to just appear out of natural processes. You can try. They're trying to explain it that way, but if you're trying to explain how a donut came into existence, but you're ruling out agency, well, you're going to be stunted in your science. So, like, just looking at it from as objective position as possible and understanding your fundamental worldview and how that affects how you look at things.
Are they currently attempting to create life in a laboratory? And where are they at?
Lots of universities all over the world.
I mean, where they're, like you were saying, there's so many big gaps in their explanations, and they don't even know currently how big the gaps are. How would they even
So
start, I
Right.
guess.
That's a good question.
yeah,
Mhm.
it is such a significant problem that they basically are trying to simplify the problem, right? So it's like, okay, how can we get amino acids from inert chemicals, right? So like, let's think about the conditions of early Earth. What chemicals were there? How could those turn into the amino acids, which is the first building blocks, just the letters, in a way that would be relevant, right? So so I'm alluding to an experiment that was done. It's a key experiment. It was done in like 1953, and it's the Miller-Urey experiment. It's probably like the biggest breakthrough in origin of life that's ever happened, but it has
If you went to
significant.
public school, you learned about it. You
Yeah.
might not remember.
And you've
But
probably
you totally
heard of it.
learned
You've
about
probably
it.
heard about it. Basically, they took like a cylinder or like some gas. Like they took methane, ammonia, water vapor, and hydrogen, and then they exposed it to an electrical spark, and
Frankenstein.
basically,
Yeah, literally,
yeah.
they Frankenstein
All I
it.
can picture is Frankenstein
Yes.
lightning.
That's
Yeah,
literally
that's-
what they did. Yes.
That is
Yes.
pretty much it. That's
Yeah.
a funny analogy, but
Yes.
that's pretty much it.
Yes.
And they were able to form
Mhm.
some of the amino acids that life uses from that experiment, which was like a big breakthrough. It's like, okay, we can take these inert materials and then we get the letters needed for life, or some of the letters needed for life.
And if
Okay.
the internet had existed, they would have said, "We did it. We
Yeah.
created the building
Right.
blocks of life in a
Right.
lab."
Yeah.
But thank goodness it was not.
Well, and that's the key. Like we can create the amino acids in a lab today.
Mhm.
The problem is, how do you do it in a way that's relevant to life on Earth
Mhm.
in a chaotic environment such as a puddle, right?
Mhm.
Like the way we create amino acids in the lab, and I don't know all the exacts of this process, and maybe we can't make all of them. I don't know. I'm not really sure, but I know we can do some. That isn't necessarily extremely hard, but it takes a very you're talking like instructions, like multiple pages of instructions, and it's like, okay, have a sterilized beaker with these pure
Laboratory
Ingredients.
pure ingredients.
and
yeah.
then mix them in there, and then you'll get from that reaction you'll get 1% of that reactions after it's happened. 1% of it will be your amino acids.
And that's how. And then it's like how they don't last.
Mhm.
Yeah, because then
Like
they
you have
start
it, you're like,
breaking
"Whoa,
down.
we got it," and then they break down.
Yeah.
So how do you? So anyway, sorry.
So how do you do that in nature without
and get
all
everything.
of the lab?
Oh my.
It's crazy.
Oh.
And there's even another problem to it, because I don't know if you guys remember or recall, all amino acids can be left or right-handed.
Mhm.
So think of a molecule structure, right? Like it can form a left hand or a right hand. They're the same hands, but they're reflected, right? All life on Earth is left-handed. All the amino acids that we use are left-handed. Like the sugars that grow on a sugar cane, left-handed sugars. That makes life compatible, because they're
Wow.
all handed the same. All the amino acids. Like if there was a sugar cane that made sugar that was right-handed, we would not be able to digest it.
Right.
Like it would not be compatible with us. So when these experiments are done, you get about a 50-50 mix of right and left-handed. So somehow you have to then separate the left-hand ones to then do the chemistry of that. So you're taking, 1% of that reaction is viable amino acids. Now cut that in half again. Now you just have the left-hand ones. And now you can start building proteins from those. But you also had to have multiple chain reactions because you need multiple letters. You need multiple of those. So it's a very complex thing that we don't really understand how that happened.
We
And-
don't understand how it happened in a chaotic environment,
Right.
because we understand this plus this equals this, no problem. But the breakdown is when they're like, here's a bowl with everything you need, just step back and hope for the best,
Right.
and then you get everything we have on Earth, and that's where the breakdown happens. Yeah.
Yeah.
How is it sustained?
Yeah, and how do you not have mutation? How do you not have instant death? How do you not have
because remember,
Which they
like,
say like numbers, right?
the
They throw a
amino
number game
acids
in.
are the letters.
Mhm.
So we're just talking about the letters of the alphabet, just getting the letters of the alphabet. From there, you have to form words, which is really the hardest part, right? Because, like, the alphabet soup analogy, like, you need to get the right information in the right order. Because, so how proteins work, right? Proteins are the key pieces, and you can think of them as three-dimensional puzzle pieces that have functions. And, like, the reason, like, I don't know if you've heard the term protein folding, but, like, so you get these amino acids in the right order. That creates a new molecule that then folds in a certain way to create a three-dimensional piece of the puzzle. That piece has a specific role to play in the object. So, like, you think about this chair, you would have a protein that would fold in a way that, like, made a seat out of the shape. That's oversimplified, but, like, that's kind of what we're talking about. Is, like, there's a huge area of research going on right now with AI specifically on figuring out, okay, let's start building our own proteins by running a bunch of simulations on saying, if we put the amino acids in this order, does it fold to make a shape that's useful for some kind of effort? Like, AI is running through all of those potential chances and saying, okay, if we could just have a protein that did this and blocked this receptor for this thing, we could cure this disease. And, like, it's a huge area that's exploding in bioengineering, and, like, we'll probably see the fruits of that soon, if not currently. So, like, these proteins are complicated structures that then, like, they're complicated structures that form parts for even more complicated things.
Which then have a structure that walks alongside of it and unfolds it
So,
to
like,
copy it.
Like a ribosome, you might have heard that word. That's a multi-part protein machine, and what it does is it goes up and down the DNA and reads the genetic instructions to assemble the proteins that it's supposed to assemble. Like, it's literally this, like, thing that moves along the strand of DNA and reads the information.
It's the walking one, isn't it?
Yeah.
It, like, walks along the
No,
video.
that's a different one.
Oh, my bad.
That's a different one. But
Sorry.
that one is for cells have to transport
That's right.
things
Sorry.
into the cell. Like, you have to move this thing from here to over here. And there's a protein that, like, walks the strands of like, basically the bones of the cell. It walks those and moves things around in your cell. It's incredible. Like, these are
insane.
They're tiny machines.
Like, think about the most complicated machine that we have made as human beings. It pales in comparison to just one machine in the cell at a nanoscale. It's phenomenal. Like, our cells are way more complicated than a fighter jet, and, like, the machines that go into it. I mean, it's a different kind of thing, but you get the idea. And, like, we have, like, an ATP synthase is another one of the machines that, ATP is the primary energy chemical that cells use for driving metabolism and all of that. And the synthase is what makes the ATP for the cell that basically it makes the food for the cell to run. It's another super complex molecule that it has an axle and a rod that spins like an engineering axle that you would see in a car, but it's in a nano scale, and it turns, and, like, rotary motors, like, turn. It's crazy. You can Google and find these simulations of these machines in action, and they're mind blowing. I don't know if you saw the video that I put in the post, but there's a few clips of those workings in that video.
Flagellum tail.
The flagellum tail is another example because it has a rotary. It's basically a rotary motor. It's a boat motor basically in a cell. It's incredible. It's incredible. And talking about, like, something that gives God glory. Like, if you look at that and it's like, oh, we got a microscope good enough to see the inner workings of the cell, and we're seeing engineering and information and things that, like, we cannot replicate today. Like, we're just starting to be able to make nano machines. It's actually what Dr. Tours, a lot of his research is on. Is, like, he makes little, like, cars. Basically out of molecules, and, like, these are infinitely more complex than that. which is why he's so vocal on like, we don't know what we're doing when it comes to origin of life. Getting back to a question that you answered, and I think this really frames it well. Actually, before I get there, the Miller-Urey experiment. So I talked about the handedness. That's a problem with it. So, okay, great. We got a few of the amino acids. It's a great starting point. Presumably, there could be other processes to get the other ones. And let's say that, we figured out how they split the handedness. The next problem with the Miller-Urey is like, based on what we know now, it's unlikely that the atmosphere would have been composed the way that they put it in the experiment. Their experiment had no free oxygen. So free oxygen would be just like oxygen that's not bonded with anything, right? So free oxygen is causes oxidation really quickly, which breaks things down extremely effectively. Any free oxygen would decimate those amino acids. It would oxidize them immediately. And so in like early Earth is likely to have had free oxygen in it. So like that's another problem. So you got the handedness problem, all these things. And we're just talking about the basic letters. And we gotta form books. Like that's the goal of life, is to form books, because that would be a cell. And so so let's talk back on like, okay, counter argument. Cells, scientists will say that most likely through naturalistic explanations, the first cells were very simple, which makes sense. Okay, we're not trying to build a Ferrari, we want to build a tricycle. And from the tricycle, we'll get to a Ferrari. That's basically their argument. And I mean, that's a good argument. Like, okay, let's put the goalpost down from there. And there are things that a cell needs to do that. So like at minimum, a basic cell, and a lot of times this is called a protocell. You need protein production, right? You would need some ribosome of some kind to say, okay, we need to make proteins in order to continue and to reproduce. You would need that transportation inside the cell to get things where they need to go. You would need energy production, so synthesizing ATP. You would need a way of disposing waste from the cell, because if you don't have that, then you're going to poison the cell immediately. You need a way of replicating, and then you would need some kind of protection from the outside, right? So, like at a minimum, a protocell needs those things. Are we close to doing that? No. Like, we have things that can kind of make... Honestly, we can kind of make a protoplasm in the sense of Darwin saw, like a gooey container with a shell around it, but it has none of those features that I just talked about. Because, like, the cell wall seems like a simple aspect of a cell, right? Like, okay, I have a wall to protect it from the outside. The problem is it can't be done, right? Like, that cell wall has to know and have mechanisms to say, I want to bring in these things and expel these things. So it has to have it's a gatekeeper. And if you don't have that gatekeeper, then you have that homogeneous situation where that cell is just going to become like it's outside, and then it's like it dies. It needs to keep separation from the outside, but bring in nutrients that it needs, and then expel the waste products.
With no information given on what is poison and what is not. It just should know somehow.
It's like a mechanically functioning system that does that. Like, the cells don't have a brain like we do to say, I don't eat rocks, I eat cheeseburgers. So it has to be a mechanism that does that, and then the cell walls, every cell has to have that. So this like jelly blob that we can do with, I can't remember how it all comes together, but it's just like it's just a barrier. It's just a wall. And a wall is not good enough. You have to have a gate. You have to have multiple gates. And you have to have these processes. So here's the real, I think, litmus test for life. we can't. Okay, if I was to give the leading origin of life scientist a living bacterium, and I took a needle and I poked a hole in it, killing it, that leading life or origin researcher could not recreate that cell.
Couldn't get it back.
Couldn't get it back
working.
together.
Right.
Right? Like
You have everything
that
you need.
separation of life
Right.
and death
Right.
is a huge barrier.
Right.
Like, and we're talking about having everything right there in almost the perfect amounts in the perfect situation. All you've done is you've ruptured the cell wall, and boom, it's done. And we can't fix that. Like, that's a pretty basic thing. So think about, okay, if we can't do that, then surely we are very, very, very far away from synthesizing a cell. But that doesn't stop things like, okay, in 2010, a scientist presented to the media that what they called as the first synthetic cell. And it was a group of 25 scientists that worked for 15 years at the cost of $40 million to create a version of a bacterium with sections of man-made DNA. So there, this is a huge scientific success, right? But what did they really do? They basically read the DNA of a living bacterium and they stored that information in a computer. Next, constructed a new strand of DNA that contained the same information that they had put into that computer. Basically,
Copy and paste.
they plagiarized that information,
Right.
and they created their own DNA, and then they injected it in a real living cell
So
that already existed.
They didn't actually do anything.
No, they just well,
Well, no, not really.
I mean, it's still significant in the sense that they read DNA,
Right.
stored it digitally,
Yeah.
recreated that DNA,
Yep.
and then inserted it into a living cell.
Right.
That's pretty amazing.
Yeah.
But if you start saying we created a first man-made synthetic cell, no wonder people are misled on what
Right.
we're actually capable
Right.
of. Like,
Right.
be honest in
Mhm.
what you've done
Sure.
is the main thing that I think. Because like, it's not that it's not amazing and really cool that we did that, but like, why are you saying you did this when you really did this?
It's like looking at like the statue of David, right? Like Da Vinci, right? Is that Da Vinci, right?
Yeah.
Yes?
Did your mind
Sounds right.
One of those guys,
Yeah.
right? Chiseled an amazing statue.
One of the Ninja Turtles.
Exactly. Yes, one of the Ninja Turtles. But like, you look at that and you say, that's incredible. That's absolutely outstanding. And what if he was like, yeah, and I created everything from scratch. Like there was nothing on this pedestal, and I worked day and night to create.
Formed the marble.
Right, like
Yeah.
did the chemistry, formed the marble, poured it, built the block, all of that. But if you just so it's simple in its explanation of how people get deceived in that they say we've done this from scratch, and you're like, well, but did you like you? Yeah, and that's the sticking part, and I think that's where would you say that's where the tribalism kind of comes into play of like, look at them, they're trying to deceive the public.
Yeah.
And it's not necessarily that they're attempting to deceive, but saying, look what we did, but there is cash behind it. Like they lose their jobs and their funding if they say like, I mean, we did, but we didn't. And so of course there's deceitfulness in it, but not in the sense of like these scientists are trying to disprove religion altogether. I would kind of say.
Mostly not.
There's some. There's
Like,
some.
the sensational media is a byproduct of them needing funding.
Yes.
Right.
for
And
sure.
so
It's
you
money.
get that sensational synthetic cell headline, and now you have an investor who is like, yep, I'll contribute to that project. That sounds great. I want synthetic life.
Right.
Well, if you read between the lines and you get a little bit more detailed, you say, okay, well, there's some caveats here, and we've done something amazing, but not quite there. It's spin, really. It's PR spin to get funding, which is just the way the system is set up, unfortunately. But I think philosophical and even theological questions, right? So like, let's say scientists do create a cell in the lab. Like, what does that mean for us? Like, how do you interpret that? Like, as a Christian, like, I think it's easy for Christians to, or I think it's easy to be like, they'll never do it, and I've been guilty of that. Like, it's so impossible, it seems like, that they'll never do it. But like, 5 years ago, I would have said the AI we have today was impossible, or like decades away. But like, I mean, it exploded in a couple of years to where it's like, whoa, the AI can do what now? So like, there's like, I think it would be foolish for us to say that scientists can't do that and they're on a fool's errand. They might get to that point, but what does that mean? Hypothetically, if that happened.
Are you asking the question?
I'm
for
asking
everyone?
the question, non-hypothetical or non-rhetorical.
What would that do to your faith, you mean?
Just in general, like, how do you react to that? Like, how do you work through that with your faith, with your worldview? Does it shake it? Does it contribute it? Like, how does that affect you?
I think it means, to me, right, my gut reaction is that it means that humans are continuing to display their incredible capabilities to be incredibly worshipful to God or incredibly wicked with those kinds of advancements. I think that's how I would view it. It wouldn't shake my faith at all in the gospel. It would definitely push me to confirm that humans are ridiculously amazing in the sense that God has created them in his image, and they are capable of tremendous things that could glorify him and point people to him, and also be incredibly damaging and full of pride and full of ego and could hurt a lot of people too.
Yeah.
That's how I would view it.
Yeah. I mean, it's kind of similar to, like, think of nuclear weapons, nuclear energy, AI for helping create medicines that can save people's lives, and AI that will, turn into the Terminator. There's technology almost always has that paradigm. Like, no matter what, the printing press. It was used to print the first Bible, but then used to
lead to the internet.
I was gonna go like propaganda and World War II, but yeah.
Or dynamite.
Yeah. Mining, like every technology has that paradigm to it.
Because left to human capability, we always get a decision. What are we going to do with it?
Yeah. And usually it's all of the above.
Kind of reminds me of the Tower of Babel.
Yes.
We're constantly trying to reach heaven, trying to match the amazing power of God in one way or another.
Yeah.
Or like go without him.
Or
go without him. Like, look how great we are.
And I think that's kind of a matter of perspective. I think that we don't even realize that is what we're striving to achieve, but ultimately it is.
Yeah, absolutely.
Yeah, or it is the heart motivation of the human, but it's best not whispered or said by the mouth, because that would be exposing the heart.
Yeah. It kind of highlights the call for Christians to do all things to honor God, right? So like in our technology, the things we discover, we need to honor God in it. That's the call that we have. It's not so much like don't advance, it's use it for good, because you have a choice. This has come up multiple times in my brain the past few weeks, but like it almost always goes back to the garden and Adam and Eve in this very simplistic question of, are you going to obey or are you going to disobey? When each technology we get, we have that new question. Yeah. Are we going to use it for his glory, or are we going to use it for destruction and pride? Like, it's all like the garden is
always being played out.
Like we have all these variations of the same thing. It's simplified in the garden as this choice to eat a forbidden fruit, but that choice now has many different flavors, right? It's just an extension of that, and in every one of those choices, we are called to honor God in them, and that's the challenge that we have today. But
I think it would be amazing. To be fair, like you asked the question, like what would happen? What would happen? I think today it would be incredible for humanity to be like, look what we've done, because at least to me, it would be a minor glimpse into what God did, right? Like we like to think like, what was it like when it was just God and there was nothing and there was chaos, or, you know, like when he created all things, when it was just him. And to get a momentary glimpse into that, if we did someday, that's wild. Like I would love. There's so many times you and I have had conversations like, what would that have been like God speaking things into existence, or this or that. Like, what would you think to have been there to seen things replicated in a way that God did in the beginning, or does on a daily basis in everybody's body, so that we don't die? I think it would be amazing, but it all. Forever, that's just the human nature that we have been gifted, is we'll take that and take advantage of it. Like it happens. I hope it doesn't, but if it did, I think it would be incredible. I think it would be super cool for someone to come forward and be like, nothing, something, and be like, God literally did that for everybody, like for everybody, and continues to do it and maintain it and create. Anyway, so
yeah,
I think it would be amazing, but again, that's today. I don't know what tomorrow brings.
And I think there's so many things that would be worth working through in that case, because I think a huge factor for me is how it happened. Like, how did we create a synthetic cell? Is it in a process that could be deemed naturalistic? That would be a harder thing for me to work through. I don't think it would shake my fundamental faith in Jesus Christ, because I think that transcends that all. And I'm like, okay, God, I trust God that he did that somehow in a way that is relevant. The Bible is not a science book. So I would take that into scope, but I'd be like, okay, that raises some interesting questions about like evolution and like how we came to be. It doesn't necessarily mean the Bible is wrong or it throws everything out. It's just, okay, we have to look, like, it reminds me of like the early church, when we learned that the earth wasn't the center of the universe. Right. We had to adjust how we looked at it. And like we had so like a little bit of a history, like it was assumed that Earth was the center of the universe because God created it, and of course it is. Like we're here and we're looking out, and God's above, we're below, and like that was the paradigm. And then it was like we started looking. We got telescopes. We started looking out, and we learned that that's not the case. The sun, we circle around the sun, and the sun circles around the Milky Way, and like we're in this random but very good spot in the Milky Way, and like. We had to frame our theology differently. Like, we had to say, okay, we were mistaken in thinking that it was important for us to be the center of the universe. Or like we had tied in our observations into our theology the wrong way. And that takes a shift. And so like, I think that's what the role of Christians needs to be, is saying, okay, science is saying like if we created a cell in the lab in a naturalistic, relevant way, which I'm highly skeptical of, we would have to just say, okay, what does that mean? And I think we'd have to work through that systematically. I honestly don't think we will. I think it'll be more likely that it's like, okay, we created a cell. If we can get there in a very advanced laboratory and it costs billions of dollars, like that's probably more likely what would happen. And we're probably talking like, I don't know how long, but far away in the future. And if that's the case, it's like, oh, it took us billions of dollars in an advanced laboratory and tons of research and all of this to kind of do what God did on a huge, greater scale. Like, that just gives him glory, like extraordinary glory. And like, even if it was the first approach, where it was more of a naturalistic, relevant way, okay, well, we have the universe that's fine-tuned to make that happen. So it really, ultimately, you just push the problem back. Okay, we got life figured out. Okay, well, what about reality itself? The universe. Like, where did that come from? You know, and it's like, okay, so you solved one problem, and now you just have a great, bigger problem. And God still is the best explanation for that. Like, how do we fine-tune things to make this, set things up just right so that life could do this incredible thing?
You and I had this conversation yesterday, though, because we were like, why is this so hard? Because you were listening to Tour and Lee, and they're like taking in their sort of biases and personalities and all of that. And I think what was interesting, what you brought up, and I've been thinking about it since yesterday, just like, oh, it's so true. And with this, it's good for us as followers of the Lord and believers in the sovereign Lord not to just create more problems, right? Like, you're like, okay, sure, you figured that out, and this is not a knock on you, but you extrapolate that and you kind of have what we have today. And the conversation you watched yesterday, where you have this tribal mindset of like science over here, religion over here, but really they've melded together. You just don't see it as often, or we're working our way through it. But when Christians or people of religion of any kind look at, say that this happens, and we say, you know, cool, you did that, but what about the fine tuning of the universe and stuff like that? Instead of just saying, good job, what about? Like, being involved in it and being like, amazing. How do we take that different, as opposed to what I think we habitually fall into, which is like, shut that down and look over here, shut that down and look over here, instead of incorporating ourselves into it and be like, that's pretty stinking amazing. Let's look further into that as like details and like the universe and the human consciousness. How does that apply? Does it? If it doesn't, have you considered the thing that has created it, all that? Anyway.
Yeah, I mean, that speaks to the criticism of a lot of this perspective. And it's usually summarized with the phrase, God of the gaps.
Yeah.
Right? So it's like, okay, and like, God of the gaps is not a good argument because it's not productive, right? It's just saying, we don't understand that, so it must be God, the end. Like, and it's like, that, like
with lightning, when we didn't understand lightning, it was like, God
Thor
is angry. Thor's throwing his hammer at the end, and we're like, actually, we figured it out. Like, but then we just move that goalpost. Like, well, we don't know how life's so God. Like, not that that's wrong, but that's the concept of it. We don't know why cheese stinks. It must be God. Don't ask questions.
And I think the better position to take, in my opinion, is like, how can we contribute our bias towards advancing science? So like, how does thinking that there is an intelligent creator designing all of this change how we approach science and the experiments we do in these areas? So it's like, okay, instead of trying to spend all this effort trying to make prebiotic or trying to make life in a way that would have been on Earth a long time ago, let's just try to make the life in general, and like, that would be like more akin to a designer. Like, let's take the restrictions out and like just see what we can accomplish. You know, that's one possible. There's probably a million other contributing ways that we can approach this differently than someone who has a different bias. It's like, so instead of just saying your science is dumb and it'll never get anywhere, let's say, how can we advance this, but with our perspective of intelligent agency? Like, we're not trying to shut down science, very much the opposite. Like, and it goes back to the foundations of science itself. Like, the fundamental motivation for science was started by trying to understand who God is and what he's created. And it's like, that is the motive of Christian scientists today. like that can lead places that an atheist might not go down. So like how instead of shutting it down, let's contribute to it and move things forward with positive things instead of just dismissing things.
As much as you're able, live peaceably among all men.
There you go.
Call dang it.
It's good verse. Good verse. So I have so many questions and things, but I'll just go to one because I think it's super applicable right now. So we're getting ready to enter into the God Gap season, known as Christmas. And so I've got so many, just listening and taking notes, I'm like, okay, all right, I've got so many questions because this is God Gap season where we go, God became like existent in Mary's tummy.
Mm-hmm.
And that happened through supernatural, miraculous things. Have fun opening your presents, and I think I have so many just considering the complexity of a cell and everything we've talked about, I'm like, okay, so now I'm picturing Mary and I'm picturing these supernatural cells that are infused upon Mary's womb by the Holy Spirit. And how do we scientifically explain the incarnation? Because this is a massive thing. I just got done reading a book on Christmas, and it's just billions of people are going to be celebrating something they don't even understand. They're not even thinking through this concept of incarnation.
Mm-hmm.
But we'll sing hymns about it. It's in every shopping center. It's in every IV. It's the songs that are just like totally taken for granted. And so talk to me about, or explain
the incarnation.
I'm
kidding.
Yes.
No
That's
problem.
actually what
Yeah.
I'm actually asking that. Like
Yes.
In a cellular explanation, what is the current best explanation from a scientific perspective of the incarnation?
It didn't happen because religion's not real.
If
If you're an atheist,
Yes.
If you're an atheist,
Yeah.
she got pregnant
Yeah.
and they built a story around
It's
it.
all made up.
Right.
Yeah,
Like
get
I
that.
refuse to bow down to authority. The end.
Yeah.
Yep. Got it.
Yeah.
But from a Christian science
Right.
perspective,
Yes.
How can you work
how
through
are
that?
we thinking through this?
Yeah.
Sorry, and I'm sorry if that's a derailing.
No,
It's
it's an
super
interesting
curious.
question.
applicable.
It's a very interesting question,
Yeah.
and one that I'll come back to in a minute because I want to go a little bit deeper, and it's something I've been thinking about. Like, what does supernatural even mean? And this is like,
We've been talking about this
I know.
for 2 days.
I think I'm going to write an article on
Yeah.
it and post it on the blog because
Yeah.
I have a lot of thoughts on it.
Yeah.
But what is supernatural other than saying that understand how it worked,
Yep.
right? Like that's kind of the definition of supernatural. And be critical of the scientific world right now, like they hold towards things that are just as supernatural, like a multiverse
Right.
theory, right? Like that's just as supernatural as the incarnation of Mary, right? Like you can't explain it with science today. Like in some ways, our definition of supernatural gets smaller, like because lightning could have been seen as supernatural because we couldn't explain it. Like it's this mysterious force that shoots lightning bolts down and starts fires. But now we have an explanation for how that functions. So just the question of what is supernatural, I think is interesting. I would honestly shift the explanation to more miracle or basically God intervening in natural normal processes, right? So normally children get born through intimacy and through the normal ways. And I'll just leave it at
I don't
that.
understand.
Yeah. Talk to your parents.
When mommies and daddies love each other very much. No, but you have to have two separate genetic egg and sperm, two different separate genetic carriers of the ability to, and those two genetic carriers, in a sense, must be compatible with one another because that doesn't always happen.
Yeah.
So anyway, that is very important.
Yeah. So I think we can speculate on that question and say, well, Mary obviously had eggs. She had half of the genetic material needed. And I would say that it's likely that that actually was used because the Bible
Absolutely.
very much talks about the lineage of Jesus on Mary's side. So like that's genetic information if you want to talk about it scientifically.
Yeah.
So Mary's half was contributed, and then you would have this divine half that came about, you know. So that could have been just information. That's all DNA really is information. And so it just, you know, formed the other half of the genome.
Whatever that meant when the Holy Spirit like settled upon her, like you have the idea of like if God is the designer, right? I'm saying if from the opposite end, right? Of somebody trying to understand it. And it's, if you think supernatural as, okay, if anybody gets a chance, it's a super boring book unless you ask Jake, read Flatland. Read the book Flatland.
It's interesting.
Because if you consider like if you have a 2D thing, right? A 2D piece of paper. I'm totally going to butcher it because I put it down because it's so boring.
You're mentioning Flatland when we're over time.
I'm sorry. But it helps me think through that question of like, how could this even happen?
Right.
Is if you have a 2D thing and a 3D thing walks upon or like interacts with it, how do you conceptualize that? You can't because you have a 2D mind that knows 2D world and now you have a 3D thing. Okay, so forget religion in a sense and just say you believe in a multiverse or other dimensions. What would happen if a 5th, 6th, 7th dimensional individual being, whatever you want to call it, interacts with our 3D world? That would be very difficult for us to conceptualize, observe. We would probably see its interaction and not understand how that
We'd
worked
call it
itself
supernatural.
out. We would call it supernatural. So if we, I know for me, sometimes I can look at the Holy Spirit as like wind or just like how do you conceptualize that? But if it's simply a thing, a person, an entity, an information carrier of some kind that settled upon Mary on her 3D body in a 4D 5D sense and just imposed upon her the information she needed for Christ's conception in a way that our bodies must have through egg and sperm joining within a woman's body, like you could conceptually understand how that information was given to create another human being.
And what's interesting about that is like the idea of multi-dimensions is scientific. Right? Like there are mathematical methods and mathematical frameworks for understanding math at a multi-dimensional level. Like math is all the way we could do it, but like it's part of string theory. Like string theory posits like something like 11 additional dimensions, and that's all through math. But like my thought is like we cannot conceive of those higher dimensions. So really, there's no way of saying that they're not the spiritual realm. Like you're just saying it in different words. And it's like one is supernatural because we're saying Jesus, like God and Jesus and church history. And like people are like, that's ridiculous. And then you have mathematicians and theoretical physicists talking about the same things using different words and different frameworks. And it's like, is one really more supernatural than the other?
Insert humility where you can be like, okay, we're talking about the same thing. We're calling it what makes our brains comfortable in the moment. And the implications are lifelong depending on what you subscribe to. Ascribe to. I don't know.
Does that answer your question?
It does. It's super helpful because I've thought it. Okay, so I wrote down a note of a definition as you guys were talking. So God intervening in the natural process with God providing, and we say the Holy Spirit providing the genome or the genetic material to match, and I added the word germinate, and germinate Mary's egg. In that sense. So, and it seems like, wow, that's such a Christian, like you said, crazy explanation. But if you're into the supernatural realm or the spirit realm, and you understand that God literally created something out of nothing at creation, then impregnating Mary with the Son of God, which is incredible to think about, is not hard nor beyond God's power and his previous experience to demonstrate his holiness, right? His ability to do that.
Yeah, and like
So
we can explain a lot of it
helpful,
with
actually.
scientific framing, and like whether that's how God did it or not, we can't say. But like it's plausible. Like she mentioned the multidimensional aspect, and if you think about the qualities a 4-dimensional or plus being would have, one of those would be omniscience, like because you could literally see inside of someone.
Yeah.
Like, because like you think us 3-dimensional looking at this piece of paper, and you have a circle. Like you can see inside that circle, because you're above it, looking down on it. If you're a circle, you have no concept of up or down. You just see lines. Like the idea of something see inside of that is infallible. So like there are mechanisms that make sense scientifically. I mean, I would never say like, double down on those things, but it's like you can explain it.
It's incredible how intuitive the Bible is about, like you're talking about ancient people, ancient people groups that are saying definitely God. And they don't, in the New Testament in the first century, they don't back off of that. And then you go back into the Old Testament and you find even more evidence of that with Elijah telling his servant, God, would you please open his eyes so he can see the angel armies that surround the city, and all of a sudden God's like, yep, there you go. And you're like, these are ancient people groups, like standing on this multi-dimensional view and not backing off of it and saying, no, this is how it happened. This is exactly how it happened. I find that fascinating. I find it very faith building.
Science has almost accidentally found out that, and it's just looking at it in a completely different way. And it's like, if you add those things together, you get something that harmonizes really well.
Right. Yeah.